Welcome to how I stuffed my laptop inside a Kubernetes pod. Um, I might be the only person who's happy that it's a little bit warm in here because I have an excuse if you guys fall asleep. So I'm going to go over a problem, a frustration I had while developing applications for Kubernetes and how I went around trying to solve it. So Kubernetes application development is actually very frustrating. Normally, if I'm developing something to run just on my laptop, just for myself, not for Kubernetes or anything outside Kubernetes, I can run the whole application with one button press. In my editor, if I hit F5, it will tear down the application that's running, recompile, rerun, spit out the logs. Everything's there. Everything's just how I want. It's very simple. In Kubernetes, you have to go through this whole process to actually redeploy. So if I make a change, I have to compile the change, build it into a new container, push the container into Kubernetes. I have to figure out how to do that. So maybe I'll push it over SSH, or I'll have to figure out how to push it up to Docker Hub and pull back down. It's just a waste of time. Then once I figured out how to get it into the cluster, I have to actually redeploy it, test and experiment, as usual, as you would. Then I have to, again, SSH in, pull back logs, see what happened, if things are operating as I expected. Oh, I forgot to change this one thing, one line change, and do the whole process again. Which should be a really fast, just, hit one button, run logs, look at them, see what changed, make changes, run, right? A really fast process is slowed right down, and it's just a waste of time, right? So I was sitting there thinking, isn't this stupid? Wouldn't it be so much better if I could put my laptop inside the Kubernetes pod, inside Kubernetes, and have it so that I could run the application on my laptop in my editor the way I like it, with everything set up just how I normally would, and it would be able to reach services in the cluster. This way I'd be able to do, my local build run tests. That'd be nice. And anything that's dependent on my application could also connect to it. So usually if you're developing a application to run in a Kubernetes cluster, it doesn't run in isolation. So something else is connecting to it, making requests to it, and then it's making requests on down the line to something else. So in addition, it would be nice if I could see real traffic, real requests hitting my application and then continuing on into the cluster. Unfortunately, my laptop is a physical object, and Kubernetes is a virtual object, and I can't put a physical object inside a virtual object. So we're going to have to fake this somehow. We're limited to remote tools. In reality, right, my laptop is outside the cluster, so I have to use tools like SSH, or you can actually set up the kubectl command on your laptop to talk directly to a remote cluster. And it's helpful. You set it up, you configure it so that you can run the commands on your laptop, and it will run the commands as if you're running them in the cluster. This is actually the recommended way to set it up, and it saves you a fair bit of time, but it doesn't change everything. All it really saves you is that one SSH into the cluster before running the command. So it saves a little bit, but it's not a real solution to the problem. So in order to put, since I can't put my laptop inside the cluster, we'll have to fake it. If you go over everything I've described, It's pretty much just a bunch of, I want this thing to be able to talk to that thing. And so ultimately, it's just a networking issue. It's just, I want applications running Kubernetes to be able to talk to my laptop. I want applications on my laptop to be able to talk to things in Kubernetes. It's just networking. We should be able to do that. So I represent my laptop inside the cluster with a pod, just a proxy pod. And then we'll have to forward traffic to myself and forward traffic from myself back into the cluster somehow. Some design goals. It's basically everything we've gone over already. But before I came up with this tool, I came up with some general design goals, just things I would find unacceptable or things that also had to be in this tool. Basically, it just has to be really, really easy to use. To deploy it, it should be as simple as possible. If possible, I want to be able to reduce it to one command to set up everything I need. And again, just I want to be able to build, run tests, applications in my editor, right? And obviously, when I build, run, test in my editor, I don't want to have to reconfigure anything in Kubernetes. Just set it up once at the start, and then be able to iterate without thinking about it. So switching gears, this is I have a few short demos as part of this talk, and this is my demo setup. So the light blue boxes are pods, the dark blue boxes are services. What is actually in all of these isn't that important. This is actually just a fragment of Volta, just because that's what I've been working on most recently. If you pay attention to, just for anyone who doesn't work with Kubernetes directly, a service is basically just a form of load balancer. It's so that I don't have to think about what's the IP of that pod, what exactly do I have to connect to. I can just point my application at a service, and it will connect to one of the pods behind that service, backing that service. So it acts as kind of this nice abstraction layer between what do I have to connect to and what's actually running behind it and backing that service. If you pay attention to anything in this diagram, pay attention to this pod, because this is what I'm going to be pulling out and running on my laptop. As I said, my laptop is a physical object. It has to exist outside of the cluster, so I've just drawn a line through and put my laptop outside the cluster. We're going to need a proxy pod inside the cluster. And that's all the basic things we need. Oops. The first part is going to be outgoing traffic, so traffic from my laptop into the cluster. And there's two things we have to do for this. We have to proxy traffic destined for the Kubernetes subnet. Oh. Ta-da. Right. Thank you. So there's two things we have to do. We have to proxy any traffic that's destined for a Kubernetes subnet into Kubernetes. And then I don't want to have to think about, what exact IP do I have to connect to. I want to be able to talk to services, and those use DNS queries. So I'm going to have to split the DNS and forward Kubernetes DNS requests into the cluster as well. So those are the two things we have to forward. So my first demo, this is going to be quick, but don't worry, we'll go over it after. So for my laptop, I will run the command that sets up these two tunnels, these two pieces we just talked about. Once that's set up, I'll leave it running. And I'll SSH into a pod running in the Kubernetes cluster. You'll notice here that I connect to it by name. This voltacli.volta.service.cluster.local is actually the full name of the cluster. So once we've set up this forwarding, we can do that. We can SSH in. Once I'm inside there, just to show I am actually in and I'm connected, I'm going to devices command, get a list of devices, comes back. Simple.
So in this case here, where is the cluster actually running? Is it on your laptop or is it elsewhere?
In this particular case, it's running on my laptop, but it's independent of that. It doesn't matter. So then I'm just going to run the same command. So I've exited out of the container. I'm going to run the same command for my laptop. This Volt control is actually using the same thing in the background. It's been configured with the Volt API.volta.service.local, the same full name, and it's using the same path to get into and access the cluster. And so we get the same list of devices. Just to show that anything on my laptop can connect to it, I'll open up a web browser. So it's not just limited to my terminal. It's anything can connect. So here I connect to just a ONF instance, and I can log in as usual. Things work as you'd expect, which is quite nice.
You mean like even with the ONFs, you're accessing through the proxy, the pod? Okay.
Yes.
Do you have to run whatever you're running on your laptop? Does it have to be in Docker or Kubernetes at all? Could it just be a process in the foreground?
Any process in your laptop.
You're running it out of your IDE.
Yeah.
Right.
So you could run, like if you wanted to run the Golang or Python debugger in the IDE without having to do any of the Kubernetes stuff in your laptop.
Yes. And that's
wonderful.
That's the point, right?
Yeah.
That's I want to be able to use everything I can use on my laptop. Same as a laptop.
So are you just doing like SSH layer 2 forwarding?
In one direction, yes. I'll go through it. So demo's pretty fast. Bunch of console things happening. I'll go through just a more visual of pretty much the same thing. So the first thing we do, we just run this connect command. It sets up the forwarding, and so it's basically just traffic from my laptop to the proxy pod. The next thing we do is we SSH into this container, and from there we run the devices command. We actually run the devices command inside the container, and so it generates a load of traffic, goes down through, ultimately comes back with a response and gives me back. So I then run basically the same thing from my laptop, and it just avoids hitting the container first. I go directly to the service that it needs to connect to. And then, again, open in the browser, refer again by name. You don't have to refer to things by name. It's just I can, so it's convenient. Right? So in general, this sets up the forwarding in one direction. I think this is clear at this point, but basically anything on my laptop can connect to anything in the cluster. Switching gears for the other direction, we have outgoing traffic set up. We have outgoing traffic set up, but we need to set up incoming traffic. So again, there's sort of two things we need to do for this. We need to forward traffic that hits the proxy pod back to my laptop. And then the second thing we need to do is we need to somehow redirect services that are running, or redirect a service or multiple services that are running in the cluster to point to the proxy pod so that the proxy pod can take to my laptop. Right. So the second demo. So in this case, I will actually open up my editor and just run the application. So this is actually running locally on my laptop. Right. Um, then I'll run the command to redirect the service to my laptop. Here we go. My slow typing. So this redirects the service, sets up the forwarding from the pod back. And once that's set up, I'll rerun what I did before, and there'll be some slight differences. So again, I'll connect to the same container. And then from this container, again, I'll run the devices. If you watch in the background, you'll notice I get logs in the IDE. So I'll quit out of the container. I'll run the same command again for my laptop. And again, you'll see I get logs in the IDE. So to go through what happened, we run the affinity router. This is the component I've pulled out. What exactly it does, not super important. But I run that on my laptop. Then I set up forwarding. So I set up the forwarding from the proxy pad back to my laptop, and then I redirect the service, this Volta API service, to the proxy pod, and so it comes back to my laptop. This we connect the same way we did before. Run the device command. This time, it's obviously different. It takes the path that we've now set up for it, hits the application running on my laptop, starts generating logs. This application makes subsequent requests to other applications running in the cluster, so we actually get commands sent back into the cluster. And ultimately, same thing, ultimately get a response and get the list of devices. Same thing with device list. With this one, you might think it's a bit silly. We connect, to the Volta API service, and then it immediately sends the traffic back. In some sense, this is a waste, right? It's a silly request to send it into Kubernetes and immediately back. But the way to think about it is more that the Volta API service has done its job of masking what's behind it. Nothing needed to be reconfigured, pointed somewhere else. It's just this application is now directing traffic elsewhere, and nobody else needs to know about it. It's hidden away and masked. Again, this makes subsequent requests, ultimately succeeds. We get a list of devices. So if we look at this overall, we've circumvented, we've gone around the affinity router that was running in Kubernetes. We've redirected the traffic to the proxy pod to my laptop, and then from my laptop back in. So if we step back and look at it overall, this is functionally equivalent to if I'd stuck my laptop right here. So this is how I managed to stuff my laptop inside a Kubernetes pod. Just some final thoughts. It's worth the time to set up your environment just how you want it. Just take the time at the start to set things up so that iterating is really quick, easy, painless. And even just the time you save from having to switch mentally from developing to running a container and back it's wasted time. It's really worth the time to set things up so you don't have to do that. Second thing is, don't be afraid to reconsider bad processes. So maybe not when you first start on a project. Don't jump into a project, and you probably need to get things done at that point. But remember the things that were annoying when you started, and when you get a little bit of spare time, come back, look at them, think about, can this be done better? Can we avoid this frustration in the future? And the last thing is just make better tools. So take the things you've learned, build them into tools, and share them. It's probably helpful to somebody else. And the make better tools is just, in some sense, we already had tools for this. We had SSH, we had remote kubectl, we had everything set up, and it worked. But there's always a better way, and we're always changing how we develop software. So there's always better tools we could have, right? Thank you very much. Any questions?
So, quick question. The naming, I noticed on your laptop you had access to Kubernetes naming. Was there DNS naming? Was there anything you had to do to make that happen, or is that all built into the scripting, the setup?
So the scripting setup handles that. Obviously, I wrote the scripting, so anything I would have had to do, I just stuck into the scripting. And but no, you don't have to install any special tools.
The Kubernetes DNS is actually available outside of the pod available?
Well, okay, so it's so what I'm doing is in Mac OS by default, there's a place you can put a custom DNS path or a custom DNS. But specifically, it's not that it works on like a full DNS name. It works on a portion. So it's anything that ends in .cluster.local. So from there, I took that. I set up a special tunnel so that I could forward it into Kubernetes and then onto the Kubernetes DNS service and then get a response.
Next question. There's nothing preventing anybody from using this method or scripting even with any pod in the cluster or anything even outside of Volta? I guess it's saying, is it a good tool for any component within a Kubernetes cluster that you're working on and you need to stop and start numerous times to debug?
So in theory, yes, there's nothing stopping you from using this. It is, the only requirement has to do with that service. Sometimes we do things how we shouldn't, and we use IPs directly, or we set things up how you wouldn't want to. But I haven't yet found a case that this couldn't handle, at least in theory. Yes.
Yeah, for some pods are made up of multiple containers. So I can see how this would work to proxy. Yeah, one of my questions, or this question is about, sometimes pods are made up of multiple containers, so I can see where this will be real useful when the pod you're emulating is closer. I'll start over again. So most pods are single executables, since they're a microservice, but there are some that have several processes individually. So this looks like it wraps sort of the API or works around the services layer. Do you think it's extendable to do a single application within a pod if it's made of multiple containers? Does that make sense?
So multiple containers in a pod is basically just multiple applications running together. So in that case, all you really have to do, I had to do this for this one initially, actually. And all you really have to do is run the two containers, both take the applications out of the containers and run both of them on your laptop. Containers in pods is basically just, they have a separate file system, but they share a network space. And that way they can talk to each other. That's it. You touched on an interesting point, though, which is in some cases you have multiple pods behind a single service, or you want to look at scalability behind a single service. In that case, in theory, this concept works, but you have to do something so that you can run I want to run multiple copies in my editor or on my laptop, and redirect sort of 3 separate requests, right? It's not just I want to forward all the requests to the proxy pod, it's I want to forward the requests to 3 separate pieces of the proxy pod and forward all those to my laptop and forward it to 3 separate applications. So it's possible in theory, but I haven't gotten that far yet. So.
Any additional questions? It's interesting to see the software developer talking to each other using a particular language. so thanks, Kent, for the very nice tour. And then I think you see the GitHub link. So it is open for everybody. Thank you very much.
Thank you.